question 2. A U-tube manometer is connected to a closed tank containing air and water as shown in figure 2. At the closed end of the manometer here, the absolute air pressure is 140 kilopascal absolute. Determine the reading on the pressure gauge for a differential reading of 1.5 meter on the manometer. Express your answer in gauge pressure. Assume standard atmospheric pressure and neglect the weight of the air columns in the manometer. So in this question, we need to calculate what is the gauge pressure at this point. So means that, however, in this question, we have two kind of units. One is in gauge pressure and another one is in absolute pressure. So we need to change the unit for the absolute pressure here into the unit of the gauge pressure. So we could solve this problem like this. First, we need to change the unit of the absolute pressure here like this one. So it is given the air pressure inside this tube is 140 kilopascal. So we minus with the atmospheric pressure which is 101 kilopascal. So it is now 39 kilopascal as gauge pressure. So to calculate the value of A here, the pressure at point A here, so we need to calculate the rho GH of water until this level. So and then from this level, we found that the pressure from air will push the surface here to give more pressure at point number A, point A here. So because we have a trapped air here, so means that the pressure of gas is acts equally on all direction like this one. So means that the pressure of air here will push point number 1 here with the same amount that it push the surface here. So and then from here we could draw a line and then we could start to calculate, because this point 1 and point 2 it fulfill the idea of Pascal paradox. So we draw a line here and we could say that point 1, the pressure at point 1 here is equal to the pressure at point 2. So means that we could write P1 is equal to point 2. And then pressure at point 1 here is equal to the pressure of air. So we write it is equal to the pressure of air. So and then to calculate the pressure at point number 2 here, so pressure at point number 2, it is because of this height, mean we calculate it as rho g of this gauge fluid. The height is 1.5 meter plus the pressure of air here that push the surface of the liquid. So this pressure is the air pressure, which equal to 39 kilopascal gauge pressure. So we could calculate this from this equation. So we found that the pressure at point number A, point A is 66.8 kilopascal.